The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Saturday, December 3rd, 2022. It's day 6 of Maunaloa's eruption, Dane. Not a whole lot of change since this morning or since yesterday, really. It's the same trends continuing. Fissure 4 was sluggish yesterday, shut off, so now it's only Fissure 3. The flow was going kind of slowly, and now it's gone even a little bit more slowly. And that's really the story as far as eruption. We got a bunch of maps to show and that kind of thing, but what are your thoughts today?
Yeah, so one thing we were able to do today was continue up with our interviews with Dr. Ken Hahn, the scientist in charge of USGS, as well as the mayor of
Hawaiian Volcano Observatory.
Hawaiian Volcano Observatory. And we were able to go through all the different updates from them and answer some questions as well. So definitely check that out. And that's posted on our channel as well as on the Hawaii Tracker website, hawaiitracker.com.
Yeah, I really appreciate the collaboration of the USGS and the county and helping us bring you guys information. That's really crucial and really, really great. So, all right, I'll get into it, Dane, here. What's on screen for...
Yeah, sounds good.
For the viewers is this new live webcam from the USGS that's been playing here behind us. Let me make it bigger on a screen and put us here to the side so everyone can see it in all its glory. That's a live feed from Fissure 3 up on Maunaloa's northeast rift. That's the fountain that's shooting up. We read an update yesterday that this Kona on the side is around 150 feet tall. So it looks like it could just be a small little bubble, but that's got to be 200 feet high fountains, judging by the reported height of the cone. And we're told that this camera is about a mile away from the actual fissure, right? So it's zoomed in, and what an incredible view. And what the internet's been asking for forever now, live feed from USGS with a volcano, and we're even more remote than Kīlauea, and they got it done. Yeah, so
quite impressive that, just to be able to take advantage of all the different cellular networks up there to be able to bring this to you. We know the difficulties in providing these live streams. Two Pineapples has been doing it themselves and encountered many a difficulty along the way. It's a learning process, and it seems like USGS brought somebody in that really has some good equipment with them.
Yeah, and they mentioned that.
But we'll see how long it lasts, right? It's like a ticking bomb if the stream dies type of thing, and how long it will take to bring it back, all those questions.
Yeah, definitely check out the interview we did earlier, because they talk all about that, and Ken talks about it as if we fill the parking meter as much as it'll go, and we'll just see how long our data will last and how long they can keep it up and all of that. But certainly it's a success so far. So I'm sure that the internet is loving this. So there it is, a live view. But we're going to review the data here today, so let me keep it moving. And I did want to mention there is this other live cam. Actually, let me pause this. So hopefully choose here. Right, and start this one here. This is the UH 2.2 meter live camera. Oh, and this is not current. This is from earlier this morning. Let's get this current. Give it a second here, but the view is pretty much the same. You don't see as much on the left side because Fissure 4 is shut off, and obviously right now actually what you see is mostly those clouds. So that's been a pattern, a lot of clouds in the afternoons, and seemingly at some point overnight it does clear up for some of those views. So I can show you, this is the capture from earlier this morning, just so you can see what that flow looks like. Not so much from Fissure 4 over here anymore, but the flow front is got that crust on the surface, so you only see the glow around the edges of it, but that flow front is something like that. And then you see the open channel above that's feeding it. And just to restate some of the statistics that have been said, I want to say I read the river was 9.3 miles long. So that's a 9-mile long river. It's starting up here at this 10,000 foot elevation, and as we've been reporting, it's down below 7,000 feet, 6,800 or so, right? So it's come down. That's 3,000 feet of elevation. You can see it dropping right there over course of 9 miles, and it looks awesome and impressive and all of that. But because the mountain is so massive and it's hard to get scale on anything, it's just worth repeating those numbers there. It's as long as that river we had in 2018 in Kapoho, the difference being it's all on its side of the mountain, so you can see it all at once, rather than being on slightly flatter ground and having to be in the air to see the entire eruption site at once. It's kind of a little bit of comparison of size there.
One question I've had is, if we were to put Fissure 8 up at that same spot, how far would that lava flow reach?
Yeah, because
maybe that'd be a question for the modelers.
Right. Yeah, certainly. Yeah, because we have heard that the effusion rate, the rate of lava coming out of the ground, was still greater at Fissure 8 Ahu'aila'au in 2018 than this one, right? And there's still a lot of uncertainty.
And the vast majority of the lava flow was deposited offshore, so it's really not visible.
That's true. Yeah, that's another good point. All right, so that's the image there. Let me play you a little excerpt of the time lapse from last night. So here's when the clouds finally move out. It's a little bit after midnight. It's from the top of Mauna Kea, of course. Other places might have different views, but there you saw the flow front, and here's clouds coming in again. So that's what it looked like overnight and this morning. Let's loop in now, and we'll bring you to the most recent text updates from the USGS. So this morning's 8:45 update. As usual, I'll highlight the differences here, because a lot of this is stated for completeness. So basically, very little change over the past 24 hours. One active fissure, Fissure 3, feeding lava flow down slope. Fissures 1, 2, and 4 no longer active. And down here, Fissure 4 no longer active. HVO geologists observed only glowing cracks in the area of Fissure 4 during the eruption monitoring overflight this morning. So Fissure 4 is done. Everything's focused on Fissure 3. And Ken did state in our interview today that the longer it stays at Fissure 3 without moving somewhere else, the less likely it does move. But if it does move, it can only move downhill within the northeast rift zone based on the previous patterns and everything we know about Maunaloa. At the flow front, the lava flow is still traveling north towards DKI Saddle Road, but it has reached relatively flatter ground and slowed down significantly. As of 7 a.m. this morning, it was 2.5 miles from the Saddle Road, and the update I'm going to show you guys next here is going to show it at 2.4. And the previous day, Friday morning, it was at 2.7, so really it's come about a third of a mile in a day and a half. Give you some idea. Third of a mile in a day and a half, and it's still 2.4 miles away. Right, so you need 7 days and a half, so that's where you're getting to that close to 2 weeks, if it were to keep charging without any further change, which we know is guaranteed to happen, that further change. All right, over the past 24 hours, the advance rate was 40 feet per hour, or 13 yards, 13 meters per hour. That's down from that I think it was 45 yesterday and 40 the day before that, so it's really creeping a lot more today. And then they say that usual verbiage of the variable rates should be expected, right? And all of that why. And gas rates being repeated from December 1st. Everything else is the same. So moving to the one that was put out just an hour ago at 4:32 p.m. Very little change since this morning. When at the Fissure feeding a flow down slope. They say as of 1 p.m. today, it was 2.4 miles from the road. And the same stuff stated again there. So that's really it. Nothing is really different. They stated at the top, very little change, and that really was all the change. So let's show you the map. This is the most recent map for December 3rd at noon. So the flow front then is right here. Let me zoom it in and put the road on there as well. So there's the highway. There's the flow, and it's expected, based on those flow lines that we've said before, we'll not cover it in that detail again today, but probably to do something like that if it were to follow those flow paths. We'll see, but it's still all the way back here, and this line right here is that old Saddle Road that's now the lava viewing road traffic hazard mitigation route. So it's still a distance from there as well, and still pretty far away. Otherwise, the map is interesting because we have the fully mapped Fissure 3 flow now, and Fissure 3 is now off the map. No more Fissure line on there, just one Fissure 3 marked on the map. And because of satellite work, they've finished mapping the flows within the caldera here, which now extend all the way to this western rim, rid of the previous map. And we have this fully mapped lava flow that came from the southwest part of the caldera and flowed within a southwest summit, all the way down to here and all the way down to here, right? So you can see the fissure was probably a series of cracks that came something like that, and I can't quite draw a straight line, but you know, we have some series of cracks, some longer ones, some shorter ones, as we saw on a photograph that we shared earlier a few days ago. And you can see that some of these flows actually came down quite a ways, all the way down to here. And if I zoom it back out briefly, and you can look at the contours, 13,000 foot contour is right here, right? The 12,000 foot there, and 11,000 right there. So you can see there's actually Fissure 3 is actually up at 11,500 feet according to this contour, right? So it's coming down 4,500 feet, not that 3 that I said earlier. But on this side, 11,000 feet comes all the way to here. Zoom it way in. You can see there's one little finger. Maybe you can't see it. Let me get to the original image here. Click through. Let's go to the original. Let's click through. And let's zoom all the way in. There is that little finger right there that seems to have crossed that 11,000 foot, just that one little spot. Most of the areas, they flow down to just above 11,000 feet. You see most of this fat part of the flow with many different fingers, just above 11,000 feet, and some of these other ones just below 12,000 feet on this side. However, that's 13,300 feet all the way down to 11,000 feet on this side. That flow was coming down 2,000 feet of elevation on that hillside, so it's understandable why everyone in Kona was looking up and seeing that flow coming down. All that obviously is now better documented with this map. So that is the map. Bit moving here. Some more maps. They actually have thermal maps now. This is something they did in 2018 and do routinely in Kīlauea when they fly over the thermal imaging. And so here's a thermal image of that map. And so again, click all the way here. The blue is that slightly cooler color, and the yellows and oranges are the hotter ones. It shows you that hotter center of the lava channel, slightly cooler bank, some areas that's a little bit more crusted over, and then this whole levee system within which that channel is flowing. And so it gives you a better idea of what you're actually seeing right on the surface, right, is this map. And the flow front's interesting. You see how it really transitions from that very hot open surface, and you see more distributed heat throughout, and you see various slopes, and you see how it's trying to push forward and find that easiest path forward. So that is that full picture of December 2nd yesterday, 6:30 a.m. And they actually have a whole series evolution here. That was this one over here on the right, and November 30th, December 1st, December 2nd, how that flow has developed over time. So not only do you see the advance of the front, but you see some changes in the organization and the strength of these channels here in the upper slope too, as well as the levees. You can see where there overflows from that channel and where there's levees built out further too. Really cool stuff there for the science nerds especially. You can see here that upper flow from Fissure 4 as well. So few more maps. USGS put out a whole bunch today. They've synthesized a lot of that satellite data that we've been sharing early results from, that came from Twitter, among other places. And here is an interferogram, the INSAR image, showing all these rainbow patterns, and they've nicely labeled the areas so it's easy to understand and interpret what's going on. So this bullseye area over here is deflation, as is over here deflation. And Fissure 3 is here, and they note uplift or spreading in the areas just north of the northeast rift over here, and just west of this southwest summit area over here, right? And it might be worth, if I go back to this map, the USGS map, we're actually showing this a little bit here, and just to point it out once again, right? That's that main caldera edge there, but you can see on the topography, there are some outer cracks. This is a structural fabric that Dr. Kinhana was talking about earlier today that actually is determining what is within the summit region and what can crack open without being concerned that it's actually entering the southwest rift. That's why they make that distinction and division that way. So interferogram showing that southwest part of the summit, and it's showing uplift and spreading in these areas. And that's going to be a combination of both the ground moving, and we'll look at the GPS signals shortly, which do show the ground moving as well. But it's also incorporating whatever small changes come from lava flows that are on there as well. You can see a little bit of the, zoom in closely, see a little bit of where the scatter occurs, where that lava flow is mapped out to be there. So this pattern is beyond that, but it's still part of the summit region, right? So very interesting. And if it had gone from here, that's the connection to the southwest rift there. That's what didn't happen, and that's why we don't have any southwest rift action. This is still part of that summit complex right there. All right. Next map from the USGS is this ground surface change coherence map. So they're using satellite comparison of radar images once again, similar to that INSAR. But now they're looking at the coherence for surface change. And so now you see a much better result of where those flows actually are, and you can see how they map them for that reason there. And I'm still curious, if I zoom way into here, I'm still curious about the stuff that occurred right next to that 1949 cone right in here. There might be something going on there, but it's not quite clear. But also really cool to see these flows that came into the crater south pit right down here as well. And that's the coherence map. We have ongoing work from the Twitter army, and this from Cosme, showing now 3 frames of this advance of the lobe that we showed you guys at the 2 frame yesterday. So 1, 2, 3, that's that slow advance of the flow over the last 3 days. And further, we have from at ustorm.org synthesis here of images from a Sentinel hub, focusing in, so they've imaged this and draped it on their topography, and they've made this animation. The flow front, different views of the flow on the mountainside here. There's a summit caldera. Those are southwest rift flows. You can see there's the side. Sorry, southwest summit flows. It just comes off the tongue the wrong way. And there, that vent site, the northeast Fissure 3, with all the cloud above it. Another pan across the summit, the northeast rift, and going that 9.5 miles downhill from there, with largely the open channel and then that covered front, and there's a saddle road there at the end. So pretty cool, different views. Those who are not in a space shuttle are able to hire aircraft to fly around to get these kind of views. Next best to see all the animations made from that, in my opinion. So there it is. Let me stop it there since it started over. And let's go to one more, which is from at AR_ETSCH. Thermal map overview of the hot flows on Maunaloa, and very similar. See, everything's fitting together. There's those southwest summit flows and Fissures 1 and 2 from the northeast rift, Fissure 4 and Fissure 3, the long flow here. Nice to see it all coming together there. That's it for the maps. We'll switch to the few pictures we have chosen out here. There is a whole set of photo and video technology released today by the USGS from Maunaloa. It includes all these maps and a whole bunch of other images as well. I just thought I'd highlight a couple here, since I like to keep it at a shorter end if possible. This is an image of a USGS HVO gas specialist using an FTIR spectrometer. That's a Fourier transfer infrared spectrometer in the northeast rift zone of Maunaloa. It measures the composition of the gases being emitted during eruption by measuring how the plume absorbs infrared energy. And the results, the plume being generated by the ongoing eruption is sulfur dioxide rich, but also contains water vapor, carbon dioxide, and halogen gases such as hydrochloric acid gas and hydrofluoric acid gas. Those are not good stuff, but very cool to see them measuring that and producing those results. Right, that's the kind of thing that's then researched with in combination with the VOG studies later on, right? So that's one, and here's another scientist at USGS HVO getting video evidence and taking notes on the actual fountains and channels. Let me read you the caption. Geologist documents Fissure 3 erupting in the northeast rift zone of Maunaloa. In the field, HVO geologists measure the lava fountain and cone heights, channel widths, and lava channel dynamics. So there's just a little bit of an insight into the work USGS is doing, besides coming and talking to you guys to share what's going on there. Right, on the imagery, one more I wanted to mention is we've talked about two pineapples. They have been streaming from the lava flow from the saddle area for several days now. The evening hours, early morning hours, especially when the visibility is the best. So just for some example, there is that image of the flow front that they caught this morning. They're able to, from there, zoom into the actual fissures themselves and actually can see some of the spatter happening there. Let me see if I can get a better zoomed in view of it. Oh, there's that flow front. And I didn't do them justice by compiling this earlier ahead of time. But let's try right there and just give you guys a little peek in case you happen to be up early or can't get enough volcano imagery. You can go and watch this live stream as well. And they're zooming into those fountains. And it's live, and they're dealing with the weather out there, and they actually had a fairly simple setup today where they, well, I'm not doing them justice by showing them all that. Okay, so it's when the weather is challenging, they'll set up different cameras, and when they have more better weather, they'll set up a whole bunch of other cameras as well. So check those guys out as well. Thank you guys for all your work. Two pineapples, really cool stuff there, and I really enjoy especially these views of the flow front too. For the USGS webcams, they have a new article out today as far as all the new webcam views they've been working on for really the whole week. So now we have the M8 camera. That's the live stream that we showed you at the top, posted on YouTube. There's also the M5 camera, the M6, the M4, and now there's also an M7. We'll look at the M7 here in a second, but you can see this is an image of a webcam, one of these webcams that's been used to deploy, right? There's a camera in that case. It's got an antenna and the solar panel to power it. And this area has a lot of wind, so you really got to brace everything and make sure nothing's loose in that kind of situation. But obviously trying to limit making any kind of permanent installation there, right? So in case something happens, the flow comes that direction, you can get it out of there, ideally. If not, it's not super expensive, so no big deal. Better than having a person at risk. Here's another image of an HVO scientist installing a web camera to monitor the Northeast Rip. This is the one that's showing a live stream, so that's about a mile away there. And that's part of that signal that they're getting, right, on a mast that's installed there. So pretty cool. We heard Ken talk about that USGS HVO electronics team that is doing all this work and troubleshooting all this to make this live stream finally possible. Kevin Komabayashi and Stephen Fuke have been there for a long time. They were there back when I was a volunteer at HVO. That was a long time ago. So appreciate those guys. Shout out to those guys today, getting that live camera up. All right, so that's the release. Show you guys the M7 camera. Currently all fogged in, or recently all fogged in, but down here in the lower image, you can see the animation of the last 24 hours, and there you can see that view, wider view, and the cars below, and this is closer to the saddle on Mauna Kea than that upper camera there. And so this is more similar to a view you might get if you were on Mauna Kea Road. This was cool to hear, Dane, that they could zoom it in and out as they like. They're just working on the programming and the back end of it to do that. So it's going to be like that UH camera where they can zoom it in and out. That's pretty cool.
Yeah, definitely. It's all about, bandwidth and capacity, bit rates, all that fun stuff, trying to get the signal out and clear. And yeah, it's impressive that they're being able to do this now. I mean, this is not what we were doing in 2018, was this kind of, sophisticated watching, basically, right? The big difference is the, residential area.
Right.
But yeah.
Yeah, and of course, it's the access is restricted. It's on a military base. It's something that they want everyone to enjoy and appreciate and keep an eye on and have information about. And so I think all the extra views are a good strategy to make sure people have more to look at, right? And so really awesome to see that.
It's really the opposite of 2018, where 2018, it was a real struggle to get out the footage, right? And the footage was crucial because everything was changing so quickly. And in this one, we have so much footage, so many lives, so many different angles. It's really the opposite of 2018 in terms of coverage.
Yeah, it's really, really awesome. Those are the days we called it guerrilla broadcasting, where we were using a phone to do it live, like next to a generator, holding an iPad and trying to point on it with a pencil and not get any glare. And we've come a long ways in all the facets of everything, right? So awesome.
Right.
All right, so all the USGS webcams here, let's do a run through. Let me make sure it's reloaded now and run through here. There's that M8, that live camera, looking like perfect light right now. The M5, that one that we've showed that spatter cone rampart growing around the fissure. There it is. M6 looking up the rift, showing that fissure 3 as well. Everything looks pretty standard. There's that river of lava, the channel, looking to the east. Don't see much from the volcano side, socked in over here on the side, and there's that current view from the M7 cam. Still clouds filling the saddle there, so weather's still not ideal right now, but it may clear out as it has done in the last few nights. And farther out, MK camera. Oh, actually, this is an MK2 from the summit, so you see a little bit of glow and that plume at the top right there. And the zoomed out view would be this. So there's the whole top of the mountain, the summit, and down on the side where the plume is coming up. So yeah, that's it. At the summit itself, nothing else. See it's dark, quiet. The thermal showing no new heat, still cooling. And the south pit camera, unfortunately, has been out since October, which is this would have been a cool one to see those flows that spilled in here. On this view, they should have come in and have something like that, but at least not on a web. Those images are. Well, actually, that's the MO, and I guess this is a south pit right here. This is the one that we see them coming. So not a whole lot else to see. Southwest Rift showing clouds as well. That's all the cameras. So with that, we'll turn to some of the signals, starting with earthquakes. And there's 2 mountains to look at. We'll start with Maunaloa, of course. Only 1 earthquake down here on the northeast flank. Not a whole lot of those. This is really slowed down, and still some levels of earthquakes here underneath Mokuaweoveo and this southwest summit area, where we now know that magma intruded this area, erupted out of that crack, and enough of it stayed in there to cause the ground to be swollen afterwards, picked up by the INSAR. And that's a similar story to over here too. Right, and to get into a little bit more detail on this, let's look at the earthquake rates on Mauna Loa and some of the other geophysical signals. Earthquake rates are still down, so there are earthquakes occurring, but not at any alarming rates. It's more the distribution that we're tracking just to try to get some little clues of what's going on. So the peak was really on that day of the eruption, morning after the eruption, as the magma was migrating from the summit into the northeast rift, especially. And here it is, how that eruptive week looks on the year, and our eruptive month looks in the last 5 years. And that's the context of it all. Earthquakes over the last week, earthquakes over the last month. That's the whole pattern of where the magma intruded, right? There's a blade that way and a blade that way, and it's pushing to the side there and there, and that's what's causing pressure to cause earthquakes over here and all the stuff elsewhere all around. And we'll go past the cross sections. The tilt, we still don't see much because the scale is blown out from that initial tilt and then recovery of the ground. So we're not still continuing that recovery trend here, and really don't see much useful that's worth sharing. But the last things to look at are this GPS line. The GPS line from MOKP to MLSP, that's north to south across the caldera. It's kind of north to south. It's from one side to the other. It's oriented like this. So in any case, it works out. So you can see that it was spreading apart as magma was coming in and wedging its way in and pushing us 2 sides apart at that rate. That looked a lot faster than this when the scale was different. The scale is much higher now. So we actually jumped from this level, which is right above 0, we'll call it 0.01 or something. The highest point on here is somewhere around 0.36. So we're looking at it jumped 36 centimeters, right? It actually wedged open 36 centimeters. And then since then has sagged back to come closer together about 5 centimeters or so. So it really wedged out a whole bunch and then settled in a little. And looking at the vertical signal, that's this up over here. I can maybe zoom in on that so you guys can see it better. There's that. Just can't see the numbers on the graph anymore, but there's that initial jump up and then that trend down, right? Which looks like it's still in progress, still continuing. And then here's a vertical. You can see it actually jumped up as magma was intruding towards the surface. And then as it moved away and out, then you can see that the surface has also dropped down. So it's going down and sagging together. That's the end story here. And the amount that it went up it looks like it might have gone up a couple of centimeters or so, but then since then it's dropped down. Most of the change there, the net change, has been a drop of about on the order of 30 centimeters or so. So really wedged open and then dropped down, and all the magma moving towards the northeast rift. So I'll leave it at that for the signals on Mauna Loa and come back to our earthquakes map. That kind of explains what's happening in Mauna Loa a little bit. It's not quite clear if this is part of that same collapse. We know that the thing is still sagging and dropping down at a pretty high rate. So that's the most likely explanation for these combined with the fact that there's still magma injected in these cracks areas, and they're adjusting as well to all the changes still ongoing. So let me zoom it out. And this is still just the last day, so Pahala earthquakes are ongoing still, and Kīlauea is showing some earthquakes as well. Earthquakes underneath the summit. It's kind of two clusters, one underneath Kanakakoi and one underneath Kīlauea Iki area. And of these, there was a larger one that was a 3.1 that occurred this morning at 9:30 a.m. that was felt on a lot of parts of the island, down at a depth of 2.3 kilometers. So this is within that magma storage and reservoir area of Kīlauea. And so we have some earthquakes going on there. What else is going on with Kīlauea? We've had this question come up today and several of the past few days. So let's make sure we spend at least one run through Kīlauea here. On Kīlauea, the summit lava depth, the depth of the lava lake has actually been dropping. So this is the past week. In the past week, it's dropped from somewhere around above 370 meters to down to right above 368 meters. So about 2 meters, 6 feet in the last week. And you notice it has these smaller variations on a small scale, but also the larger variations that seem to follow the deflation-inflation cycles on the tilt. This is the ground tilt that I'll scroll it up here. The ground tilt, and there's earthquakes, all these different lines of earthquakes. That was the beginning of the Maunaloa eruption right there. So deflation-inflation, still occurring events, right? And hard to tell from right there, but overall, the tilt is fairly flat, by the looks of it here. But the lake depth is actually on a decline, which is interesting there. Not a super fast decline. It's not like it's flushing out or anything like that. It's just receding very slowly. To make it more clear, here's the whole last month. Over the whole last month, we're from 72.5 down to 368.5. So that's 4 meters. You're looking at more like 13, 14 feet, something like that now over the whole last month. And looks like it was fairly steady until somewhere around, we'll call it the 15th. So before the eruption of Maunaloa, in fact, which was all the way over here, we start to see Kīlauea's lava level very slowly recede. And here on this tilt plot, maybe it's a little bit more convincing that there's no clear decrease or increase in the tilt. It seems like it's holding steady, if anything, right? Hard to see because of so many deflation-inflation events, which are probably suggesting, due to their increased frequency now, that there's more movement of magma within that feeder system below the summit, within those upper 2 miles. It's the sensitivity of the tilt meter. SO2 has been going down for a while as well. So on Kīlauea, the last SO2 measurement was in the 300s. That was before Maunaloa's eruption. Certainly, that's prior to Maunaloa's eruption in the last week. And that follows the overall trend for the whole year that the gas has been going down. Meanwhile, Summit GPS, the two sides of Kīlauea, have been still spreading apart for the most part, with little wiggles, sometimes a little bit less, and they get stuck. And this was when we had that intrusion that occurred, and it reset it, popped it back open. So there's a little bit of wiggles happening as well, including a current one right now. And similar to that phase when the intrusion occurred, it seems like a lot of the lava, or a lot of the magma that's coming to the volcano is not making it to the surface to erupt as lava in the lava lake, but it's actually being injected into that inner part of the volcano and its summit magma reservoir area. And that's the summit trend there. And on the east rift zone by Pu'o'o, the line is going down the opposite way, meaning the sides are coming closer together, meaning no magma is going in there. It's still kind of settling and sagging. So this was an area that had been accumulating magma prior to the eruption at Kīlauea summit, but really since then it's been on a decline. So that pattern is unchanged. So the east rift is not affected by this at all in any way whatsoever, and it's understandable that people are asking because of signals 2018 and the dynamics and all of that. So obviously it's a long epic tale that we go through year after year. Things change and then again and again, and so all these changes eventually could lead to resetting that system down there, but that's not what's happening right now. Right now it's Kīlauea is essentially seeding. It's a place in Maunaloa is what's took the baton here. We've described recent research that talked about how Maunaloa's shallow magma chamber, when it inflates and swells, which is what happened prior and during the beginning parts of the eruption here, that it can impede Kīlauea's shallowest summit reservoir, but not the deeper Kīlauea reservoir. So that would make sense if magma is collecting in those deeper areas and less so in the shallows. And not going into the rift zone still. Make sure I say that too. So that's the story on Kīlauea. It's similar to before. Maybe the lava lake receding is the first of a very minor visible change in the volcano. So that wraps up the earthquakes here. There is just one more thing to do, and that is to cover the VOG. So let me try to give this a reload and hope it gives me this message. Yes. Zoom in on this, and it's not going to let me, but up here it says, Maunaloa is erupting, a VOG plume remains in the upper levels of the atmosphere, limited impacts on near-surface air quality are expected, gas emission conditions may change rapidly. So they've tried to refine this forecast. We talked about 2 volcanoes, they're both putting out VOG, right? Maunaloa a lot more than Kīlauea. Kīlauea in a range of, call it 300 tons per day right now, and Maunaloa in a range of 180,000 tons per day. So a huge discrepancy there. But 2 sources, and you can see it is affecting areas, and a lot of this area where it's flying up at the top of the mountain is that eruption area where it's uninhabited. So it's really more concerned about places like Pahala, Nalehu, Ocean View, or South Kona and Kīlauea Kona itself. And so those are the areas that might have some impacts. And once again, as the gas doctor stated, it's just like a radar forecast. It gives you the idea of whether you should pack an umbrella that day, be prepared for those conditions, but it doesn't tell you whether it's actually going to rain or you're going to actually encounter that VOG. That's something you have to judge for yourself as you go through your day. So that, I think, catches us up today, Dane. That's just a run through. We don't need to look at all the surface measurements. They're all still in the green. And anything on a VOG, first of all, before we move on to maybe 1 or 2 questions?
Yeah, just on the VOG, I mean, we're going to be continuing to push the VOG survey that we're trying to put out there. That is on hawaiitracker.com. I'm also going to drop the link again here in chat for everybody. If you're on the island and you smell VOG, or even if you don't, I recommend, it'll help us out immensely to try and figure out how to forecast the VOG. This is all based on stuff that was done in Iceland. It's using their survey, and we're getting help from Professor Evgenia Ilyaninskaya from Leeds University, and we really appreciate anybody that's able to make a report on this thing. And the more reports, the more data, the more we're going to be able to try and refine things for next time. We haven't had a Maunaloa eruption in 38 years. That means all the sensors and things like that, the placements and all that, we never really knew, exactly where to put it for a Maunaloa eruption. Well, now we're getting that real-time information, right? That stress test, and hey, we probably got to make some changes. This is going to be able to hopefully help make some of those changes. So there was a couple questions, Phil, but I want to acknowledge some super chats real quick, if that's all right.
Yeah.
All right. We had a longtime supporter, Gary Bryan, come through with a $50 donation. Philip and Dane, you guys rock. Thank you for the pun, Gary, and the longtime support. We also had a $15 super chat from Stephanie. It says, some coffee as a huge thank you for always putting out great information and continuous hard work. I appreciate the support there, Stephanie. All right. Questions? Time?
Yeah, let's do a couple, but let's get out of here quicker because it is the weekend.
There was one really good one. Right, there was one really good one I wanted to just say. Arthur asks, are lava tubes might start developing soon? ?
Yeah, I'm not sure. I'm not sure if they will. They certainly could, but that's something you typically see more with the Pahoehoe flows, and I think the A'a flows of Mauna Loa quite often have those open channels that persist a long way down. Maybe, once it's in this flatter spot, maybe some part of it ends up with a tube in that flatter spot. Maybe that's what Arthur is referring to. So that's a good point, that different slopes, could have different kinds of development. And we did actually even hear Dr. Han today refer to how the flow could get more fluid and change its character in that way if it develops a certain way. And certainly in that case, then absolutely yes, that could further promote the development of lava tubes. And generally speaking, that makes the delivery of lava to the flow front more efficient. It's not kind of spreading out and losing all that heat everywhere. So as far as hazard, that's not a good thing. It's interesting in science, but that's not something we really hope to see really nice open channels. The whole eruption is fine for us here. Like, good point. Mahalo, Arthur.
Right. Well, I think we will try and get out of here a little bit early. I don't think we're going to try and live stream tomorrow, but maybe Monday.
Yeah, sounds good. Yeah, unless something drastic happens, of course, and if something major changes, but it keeps advancing at that, it's gonna change 0.2 miles from day to day, and now we're down to one vent. It's not gonna shut off. And we've got the mapping done. We've got new webcams. There's plenty of images to look at nonstop now, 24/7. So yeah, when we're needed, we'll step up, obviously, but also would like to take a day to rest as well.
Right.
Yeah.
Can't burn out on this thing early and then it actually do something and we already be like, crashed out basically.
Yeah. So resting means we'll still be posting some stuff, and we just probably won't do the actual live video.
There will be posts. We'll be posting on hawaiitracker.com as well as the Hawaii Tracker Facebook group. I will try and share some of that onto the YouTube, but no promises on that one. Definitely, if you want to be caught up on the latest and see all the flow of information, check out our the Facebook group, Hawaii Tracker, and I also can drop the link to our newish reactivated Telegram that has come out of its dormancy since 2018. We've kept it in hiding, kept it in a cave, and now it's it's time for that thing to come back out and see the light of day.
Yeah, it's a good platform for those who don't want to come on to the other options.
Right. All right. Well, thank you guys. That'll be it for me.
Thanks, Dane. And that's it for both of us. So until tomorrow in text and other post format, and then likely in a couple of days on Monday, we'll try to come back to you guys in video form. What?
Yeah, I'll answer a question in the comments. Sorry. There's a question that I missed, but I'll put it in the comments.
All right. Well, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everybody.